Hi there, welcome to Physical Geography. In this class, we're going to be talking about plate tectonics and specifically about diverging boundaries. So you may remember we talked about that there are three different types of plate boundaries that are out there. You have converging boundaries, which are two plates coming together. You have diverging boundaries, two plates coming apart. And then you have transform boundaries, which are not coming together or apart. They're just sliding side by side like this. So nothing's going under anything else and nothing's opening up space between them either. So convergent, divergent, and transform. So at divergent boundaries, the general idea is that plates are moving apart. They're splitting. The Earth is tearing apart along the lithosphere. Remember, the lithosphere is the hard sphere. It's the crust plus the top part of the mantle, which is also hard too. It's the hard sphere. So that hard sphere is pulling apart and it's splitting and tearing. And that area where that's happening is called the spreading zone. See the picture there? The spreading zone is where the tearing and the ripping is happening. When you have a break in the Earth that moves, that's called a fault. So you see those faults are developing on either side of that spreading zone. And as we said in the video about introduction to plate tectonics, down below is the asthenosphere, the weak sphere, and that's what allows that lithosphere plate on top to move because the asthenosphere is a little bit squishy and that hard plate on top has some give and it can move along on top. And so now we're going to look at the results. Like, what do you actually get when you get two plates that are coming apart? What kinds of things can we see? And remember that we said that tecton in Greek means build. So plate tectonics is about the things that are built through plate movements, things that are built through plate movements. And here I'm going to give you some possibilities. But before we jump in, let me just say that there's many diverging boundaries all around the world in a whole system. And at different places, you're going to see different ones of these different options on this list here. You have ridges, rift valleys, volcanoes. Not every place with a diverging boundary has volcanoes, for example. So you have to keep in mind that I'm giving you the types of things that can happen, but in many places you just see one or some combination of these and not necessarily all of them. So we're going to see in a moment that most of the diverging boundaries are actually under the ocean, under the ocean. So a lot of what we're going to see right here in this diagram takes place under the ocean. Not always, but most of the time. And so when we see those faults in your side, there's little cracks. And then magma can get up through the cracks and then becomes lava as it comes out. It forms ridges. The ridges kind of spill out on either side. Those are the ridges on either side that keep forming. So you get ridges and then you get more ridges. And as it keeps spreading outward, it opens up space for more and more ridges to come out. So what you're going to get is kind of an effect where you get a conveyor belt of many ridges. Here's a great diagram that shows that. You see the magma coming through the cracks in the middle there at the diverging boundary, many different cracks. And then as it comes out, it forms those ridges. But because the plate is diverging, see the two arrows going apart, it's carrying the ridges with it away from the boundary. So you get more and more and more ridges like on a conveyor belt that just keeps moving and moving, adding and adding more ridges to it. So that's what the ocean floor will look like around a diverging boundary. It will look like that, like many ridges in a row. And we're going to see in a moment that there's a whole system of ridges like that called the mid-ocean ridge system. It's the major system of diverging boundaries in the world. And from another perspective, we can also say that here at the diverging boundaries, where these ridges are coming out from below in the asthenosphere and coming up onto the surface of the Earth, even though it's underwater, we can say that new crust is being born. New crust, new lithosphere is being born there because it's being moved from the asthenosphere out to the crust, the lithosphere, the surface of the Earth. Keep that in mind because in the converging boundaries is where Earth is recycled. So it's born in the diverging boundaries. It's going to be recycled in the converging boundaries. So ridges is the first thing we can get in a spreading zone. The second thing we can get is rift valleys. Rift valleys. A rift is a tear, a rip. Okay, so it's a tear valley, a rip valley. Earth is splitting apart. And what you see in the picture here is there's faults on either side. There are breaks that move. And that allows a big block, sometimes a big block in the middle there, to then fall down or slip down further down below the two sides of the plate on one side and a plate on the other side. So that middle part there is drop down, creates a basin or bowl shape, and that is the valley. That's the Rift Valley. That can be big that can be small, depending on where you are. It can be huge. So this diagram shows that up close and personal. You see the part in the middle there has separated. It's faulted on either side, and it's dropped down and created this big basin. And then the plates on either side are moving away. And the further they move, the more the basin drops down and creates a valley. So we have ridges, we have rift valleys, and a third thing that can form along spreading zones is volcanoes. They could be submarine volcanoes under the water, or they could be on land too. But there are many chains of volcanoes under the ocean that we don't even see because they're not high enough, at least yet, to get out of the water. And they can form along diverging plate boundaries. Just to be clear, when we do converging boundaries later, they also form volcanoes too. So both diverging boundaries and converging boundaries can create volcanoes. So the three general types of things that we could see around a spreading zone are ridges, rift valleys, and volcanoes, some combination of those. The vast majority of diverging boundaries around the world are underwater, and they form what's called the mid-ocean ridge system, MOR, mid-ocean ridge system, because it's in the middle of the ocean. They're at the bottom of the ocean, out in the middle. If you see it on this map, you can look and see, oh, the red line, that's the mid-ocean ridge system around the world. It's mostly in the ocean, and it's mostly out in the middle of the ocean as opposed to along coasts. The mid-ocean ridge system, MOR, is the world's longest continuous feature. It's longer than any other set of mountains on land or anything like that. It's the longest continuous feature on the surface of the earth. It's sort of like the seams of a baseball. You know how a baseball, the seams go all the way around the ball? It's sort of like that, meaning that that mid-ocean ridge goes from the Atlantic out the other side, the Indian Ocean, comes up in the Pacific. So it's really all around the world. And so just to be clear, what are we talking about? We're talking about the earth is splitting at a diverging boundary, and it's splitting out in the middle of the ocean. So you see on this bathymetric map here, it's showing you the bottom of the ocean, and it's showing you the ocean floor, the bathymetry. You can see there's this crack, right, way out in the Atlantic Ocean. Now, we don't see it from above on a boat because you can't see through the water, but it's down there. And we know that thanks to sonar. Sonar allowed us to see the depth of the ocean, and then we started to notice these mid-ocean ridges. That was one of the big tip-offs that led to the theory of plate tectonics. Once we saw the seams of the baseball, so to speak, we saw the mid-ocean ridge all around the world. So what we're looking at in this picture right here is a plate on one side, the North American plate, and the African plate on the other side, and they are literally moving apart. That means that new Earth is being born out of the middle of the ocean at that crust, but you can't see it because it's deep under the water. Here's another shot of the mid-ocean ridge. You can see there's literally all these ridges around, it seems like the baseball there, all around the whole mid-ocean ridge system. Look up in the top towards the middle of the map where Iceland is, and notice that the mid-ocean ridge actually goes through that little island up there, Iceland. We can see the mid-ocean ridge on land. So here's Iceland, an island up in the North Atlantic. Top of it touches the Arctic Circle. And you can see that there's two plates. There's the North American plate on the west side, and there's the east side Eurasian plate. And those two plates are diverging. Sure enough, there's a bunch of volcanoes right smack through the middle of Iceland along that diverging boundary, which are the red triangles. On this map on the right, where you see Iceland towards the top, it says Mid-Atlantic Ridge, which is a subset of the Mid-Ocean Ridge, and that's what's going right through Iceland. So Iceland is basically cracking apart, but over thousands of years. If we were to go to Iceland, we could get off the plane, take a taxi, an Uber out there somewhere, and we could actually walk through the Mid-Atlantic Ridge. We could walk through the Mid-Ocean Ridge system. There it is right there. We can see it. If you want to know how far it has spread, how far this diverging boundary has diverged over time, the answer is that far. It's showing you right there on the screen, and that's how far it's moved over time. And in this area, the diverging boundary zone, the spreading zone within Iceland, you can see there's a whole line of volcanoes. And just as a side note, that's not the only cause of those volcanoes, because Iceland is a special location. Iceland is both on a diverging boundary, but Iceland also is over a hotspot. A hotspot we haven't talked about That's a big blob of magma that got super hot by being deep down into the earth, close to the core a long time ago, and rose up and just kind of sits underneath the lithosphere down in the astrosphere. Very, very hot, super hot. And occasionally it sends up streams of magma that become lava and form volcanic islands. Hawaii, for example, a chain of hotspot islands. And Iceland is like that. Iceland was formed from a hotspot erupting up over the surface and creating Iceland. But then it's split as well by the diverging boundary. So Iceland's a very unusual place in terms of plate tectonics. And you see here these volcanoes in Iceland. So you literally have fire and ice because you have on the right Hekla volcano where it's covered in ice and yet lava can come out of that thing. So you literally have hot lava, like orange hot lava on ice, fire and ice. So from the land of fire and ice, let's go to the land of the safari, East Africa. East Africa has a much bigger diverging boundary. It is called the Great Rift Valley. And if you look on this map here of Africa, you can see it goes right down the eastern side of Africa. And so in the future, they say that the eastern part of Africa, countries like Ethiopia, Somalia, they will literally split off and become a little subcontinent of their own out in the ocean. But that's thousands of years away. So the Great Rift Valley is one of Africa's major features, along with the Sahara Desert, the Congo rainforest, and the Nile River. You have the Great Rift Valley. And what's happening there, you can see in the top right, there's actually smaller plates, smaller than the African plate. There's the Nubian plate, Somali plate. These plates are moving apart from each other. And as they move apart, that middle part that is separated through the faults on either side, it becomes separated off on its own. It then is free to drop down, which creates that basin shape, which is the valley. So that valley goes on and on and on down through 6,000 miles in the east of Africa. It actually keeps going. Actually, it goes through Africa and then it goes into the Red Sea, and that's Red Sea is splitting too. The Red Sea, they say, will open up and become part of the ocean eventually. So here is the Great Rift Valley in Kenya. You can see this one is much bigger than Iceland. So all we can see in this picture is one side of it. Then it goes down to the valley floor. That's the part that dropped down, that block in the middle that was faulted on either side. It slipped down, created that big valley floor. And just for perspective, this is where lots of animals live. The safari was born here in Kenya, the idea of having a safari. And this area is where the Maasai people live, very famous warriors in Kenya and East Africa. So the Rift Valley is a very big cultural aspect of East Africa, not just some plates and plate tectonics. Here's a Maasai warrior. You can see this is looking the other way at the Rift Valley. So there's literally many, many miles between one side of this Rift Valley and the other. That basin, that valley floor is very, very large. It's huge. And there are whole tribes that inhabit that valley. So there's a highway going through there. There's animals all over the place. It's a very, very big region. Not only that, but the Great Rift Valley is a major cultural region. There's cities, there's lots of lakes in there called Rift Valley Lakes. So when the Rift Valley pulls apart, along the two cracks on either side, you get all these finger lakes because those cracks are elongated. So they're kind of like long, skinny lakes. Many, many, many lakes, Lake Nakuru, Lake Baringo. And this whole area, the Rift Valley and the Rift Valley Lakes, is home to some of the most famous wildlife in the world, the hippos, the lions. They're all there, and people come from all over the world to see that. So I could fill up 100 more slide presentations with all the wildlife and the interesting things in the Rift Valley, but I encourage you to Google it, poke around a little bit, see what kind of animals and plants and birds and people and tribes live in the Rift Valley. Another thing about the Rift Valley is that it's very big in agriculture. Those slopes are very, very fertile, and so there's lots of tea plantations, coffee plantations, just lots of agriculture in general up in the Rift Valley. It's a very well-known part of Kenya, Tanzania, all these East African countries. If we go up from Kenya to the north to Ethiopia, here's another part of the Great Rift Valley. This is Erta volcano, and this volcano is literally ripping apart. You can see the crust is tearing apart right there, and the sulfur dioxide is coming out from below. So literally, we can see the divergence on the picture. And a picture like this gives you the idea that there's a lot of heat down there below the surface. And that's the case. So this area, the East African Rift Valley, is actually one of the world's prime spots for geothermal energy. because the Earth is very hot, not too far down below the surface. So just to be clear why that is, again, so the Rift Valley is pulling apart, the basin drops down in the middle, and as it keeps pulling apart, it's actually stretching that valley floor. It's stretched sideways as it diverges, and it's pulled apart, and that thins it out. And that helps to keep it very, very hot close to the surface because the crust gets thinner. So if you're interested in geothermal energy, renewable energy at all, I encourage you to look at East Africa and see some of the projects that they're building there, including in Ethiopia, Kenya, and other countries. So that's a look at diverging boundaries. We can explore how all the different neighborhoods of the mid-ocean ridge system have different effects on their ecosystems and the land around it. But overall, the diverging boundaries are coming apart and new Earth is being born there, coming through the cracks from the asthenosphere up to the surface. Being born meaning lava is coming out, and then it's going to move out sideways on that sort of chain or conveyor belt moving outwards. And then we're going to see that at converging boundaries, they're going to come together and some of that Earth is going to be recycled back in. So there's sort of an economy where you gain Earth here and then you lose it over here. And our big system of diverging boundaries is the mid-ocean ridge system. We're going to contrast that with the biggest system of converging boundaries, which is going to be the Ring of Fire. So we have the Ring of Fire, biggest system of converging boundaries, and the mid-ocean ridge system, the MOR, the biggest system of diverging boundaries. And those two systems go a long way to explaining where the plate boundaries are within plate tectonics.